Writing a custom tool for an AI agent usually means writing it for LangChain, rewriting it for Llama Index, then adapting it for Claude Desktop. The effort multiplies with every new framework you adopt, creating a fragmented system instead of a unified machine. The Model Context Protocol, or MCP, solves this by standardizing how AI models communicate with external data and tools. You write the tool once, and any MCP-compatible client can use it. We are going to build a custom MCP server from scratch and wire it directly to a LangGraph agent, allowing the LLM to execute our custom tools automatically. To follow along, you need a local Python environment, an active LLM API key, and a blank code editor. By building with MCP, developers stop maintaining fragile one-off API connections and instead create universal AI infrastructure that plugs into any platform right out of the box. Open your terminal. We need to install our core dependencies. Run pip install langchain MCP-adapters, LangGraph, MCP, and langchain Anthropic. The langchain MCP-adapters package acts as the bridge for our system. It reads standardized MCP outputs and translates them into a format LangChain and LangGraph natively understand. Switch over to your code editor and create a new file named server.py. Start by importing the fastMCP class. Initialize the server object by assigning it a clear name. We will call ours math. Next, write a standard Python function that takes two numbers and multiplies them. The critical part here is including strict type hints. The LLM reads these hints to understand exactly what inputs your tool requires to execute. Directly above that function, add the @server.tool decorator. That single decorator takes a standard local function and exposes it over the Model Context Protocol. It is now a discoverable tool for any client connecting to this server. First, create a second file named client.py. Because MCP handles communication over streams, our execution code needs to be wrapped in an asynchronous Python block to properly manage the requests. Here is how the system connects. The LLM agent talks to our LangChain MCP client, which uses an input-output pathway, Stadio Transport, to communicate with the fast MCP server. To open that pathway, we configure Stadio server parameters, setting the command to Python and passing server.py as the argument. Pay close attention to the command parameter. If your system or virtual environment uses Python 3 instead of Python, you must use that exact alias here, otherwise the client will fail to launch the server. With the parameters set, we pass them into create session to initialize the asynchronous connection between our client and the server. Running the server as a separate process via Stadio isolates the execution environment. The client doesn't need to know how the server works internally. It just reads the inputs and outputs over the transport layer. Now that the connection is active, the client needs to ask the server what tools are available. We call load MCP tools, passing in our active session. This function fetches our math tool and translates it into a standard LangChain tool object. Next, we initialize our LLM model instance. We will set up Chat Anthropic. We use LangGraph's create-react-agent function, passing in the LLM model and the tools we just loaded from the MCP server. This firmly binds them together into a unified agent. Finally, we trigger the execution. We send a complex multiplication prompt to the agent and use an asynchronous loop to print the response stream as the agent acts. Before running this, confirm that your LLM API key is properly set as an environment variable in your terminal to prevent authentication errors. By automating tool discovery, the agent pulls in its capabilities dynamically. We bypass the tedious process of writing manual tool registration boilerplate entirely. Run the client.py script in your terminal. You will immediately see the agent begin streaming its thought process as it evaluates your math prompt. Look at this section of the output. The LLM evaluates the problem, realizes it needs the multiply tool, constructs the exact parameters, and sends the request to the server. The server computes the result and passes the law calculation back. The agent then takes that raw data, incorporates it into its context, and streams out a final, human-readable answer. We built this to connect to a LangGraph agent, but because the server uses the Model Context Protocol, you can point Claude Desktop, Cursor, or any other MCP-compatible client at that exact same server.py file, and they will be able to use the math tool without altering a single line of code.
Enhance your coding skills with us. Don't forget to subscribe to Code 5 Food for the latest updates and tutorials.